Hello everyone, welcome to 10-Minute Physiology. In today's video, I'm going to give you a short explanation as to how 3 different types of infusions affect both the extracellular fluid and the intracellular fluid. So with that, let's give it a go. So I would like to start off by talking about how water is divided up in our body. So inside the 70 kilogram man, which is going to serve as our standard, around 60% of his body weight is going to be water. So if the man weighs 70 kilograms, around 60% of that weight is going to be water. So 42 kilograms out of the 70 kilograms is water. And since there's 1 kilogram per liter, there's 42 liters of water in this man. Now, the total body water is going to be divided up into 2 major compartments. The first is going to be the ECF. So the ECF is going to make up 40% of the total body water. So if you calculate this, around 17 liters of the person's water is going to be in the extracellular fluid. The remainder is going to be in the intracellular fluid, so 25 liters. So this is going to be incredibly important to remember for the rest of the video. So now what we're going to do is we're going to look at 3 different types of infusions in this video. The first is going to be the isotonic saline infusion. The second is the solute-free infusion. And then the third is ingesting pure sodium chloride. So let's start off with the first one, the isotonic saline infusion, and see how it affects the ECF and the ICF. So in order to understand how an isotonic saline infusion would affect the ECF and ICF, let's just say we have this system. So in this system, we have 2 compartments. The first is the ICF, and the ICF is going to be 25 liters, and the tonicity is going to be 290 milliosmoles. The ECF is going to be 17 liters, and the tonicity is 290 milliosmoles. So these are the initial conditions. And dividing these 2 layers is a semi-permeable membrane that is going to be permeable to water, so water can pass between the 2 compartments. So let's just say we bring in a needle, and this needle infuses around 2 liters of isotonic saline solution into the ECF. So what happens initially is that the ECF will expand its volume by 2 liters. But what is going to be the final condition? Well, the final condition is this. So after we inject the 2 liters of isotonic saline, all of the saline that we injected into the ECF remains in the ECF. And the reason why is because when we add this isotonic saline into the ECF, we are not changing the tonicity of the ECF. Therefore, all the isotonic fluid that's added to the ECF stays in the ECF. In other words, by adding isotonic saline, we expanded the ECF without affecting the ICF. And if you don't know what tonicity is, please go to my video, Tonicity versus Osmolality. There you'll get a better understanding of what I mean. So that's what isotonic saline would do. So what about the next one? Solute-free infusion. So a solute-free infusion would either be pure water or 5% glucose solution. And we'll talk about why 5% glucose solution is considered solute-free. So in order to understand the effects of this solution, we're going to do a similar experiment. So in this, we have the 2 compartments once again, where we start off with 25 liters in the ICF and 17 liters in the ECF, and both are 290 milliosmoles. So in this experiment, we're going to inject around 2 liters of free water into the ECF. So what's going to happen? Well, in order to understand what's going to happen, we have to do a little bit of math. So what we have to do is, first of all, consider how much liters of water were infused into the ECF. So we had 2 liters of water infused into the ECF. Now remember that around 60% of the total body water is going to be in the ICF. So the 2 liters that was infused into the ECF, around 60% of this water will go into the ICF. So out of this 2 liters, 1.2 liters of it goes into the intracellular fluid. The remainder is going to remain in the extracellular fluid. So 0.8 liters will go into the ECF. So remember, out of the 2 liters of water infused, 60% of it is going to go into the ICF, and 40% of it is going to go into the ECF. So how is this going to affect the concentrations in both of these compartments? Well, in order to do that, we have to use this equation. C1 times V1 equals C2 times V2. So let's do it for the ECF. So if we were to do it for the ECF, you would take the initial concentration of 290, multiply it by 17 liters, and set it equal to the other side, and you would solve for this final concentration. And when you do that, the final concentration would be around 277 milliosmoles in the ECF. And the same would occur in the ICF. If you would do the same calculation, you would get the same value. So what did we find by this experiment? So from the free water infusion, what we see is that both volumes, the ECF and the ICF, increased. We increased by 0.8 liters in the ECF and 1.2 liters in the ICF. Now, it's important to realize that by adding free water, the majority of the water went into the intracellular fluid, and on both sides, the solute concentration was diluted. So that's going to be the effects of the free water infusion. Now, remember I talked about how isotonic glucose solution is considered solute-free. Why is that? Well, the reason why has to do with the cells themselves. So let's just say we have a cell immersed in a solution of glucose. Now on this cell, we have a glucose transporter called SGLT2. So let's just say SGLT2 brings in 2 glucose molecules. Now the cell is going to metabolize these glucose molecules really quickly. So as a result of this, by infusing glucose intravenously, it is equivalent in the long run to infusing pure water. And the reason why is because glucose is metabolized by the cell to both carbon dioxide and water, and no solutes will be left behind in the ECF. So it's equivalent to adding pure water into the ECF in the long run. So the last thing we're going to talk about is pure sodium chloride ingestion. So what is going to be the effect of this? So in order to understand this, we're going to do the same experiment where we have our 2 compartments divided by a semi-permeable membrane. We start off with 25 liters in the ICF, 17 in the ECF, and both have a tonicity of 290 milliosmoles. So what we're going to do is we're going to bring in a little bit of sodium chloride into the ECF. And we're going to bring in enough in order to raise the tonicity or osmolality to 316 milliosmoles. So what's going to happen to the ECF and ICF now? Well, in order to understand this, we have to do a little math once again. So the first thing that we're going to do is we're going to see how many milliosmoles are in the ECF. In order to do that, what we do is we take 316, multiply it by the amount of liters in the ECF, and we get the amount of milliosmoles in the ECF. And when you do this, you get 5,365. We're going to now do the same thing for the ICF. And when we do this, we multiply 290 by the volume of the ICF, and you get 7,250. So the next thing we're going to do is we're going to see how many millimoles are in the whole body. And when we do this, when we add these 2 figures together, we get 12,615. And then the last question we're going to ask is, what is the final osmolality? And in order to do this, you take this value, divide it by the total body water, and you get 300 milliosmoles. So 300 milliosmol is going to be the final osmolality of both the ECF and the ICF after ingesting pure sodium chloride. So what are the final volumes then? So by using this equation, we can find the final volumes of both the ECF and the ICF. So for the ECF, what we get by using this equation is that the final volume will be around 17.9 liters. And the final volume of the ICF will be around 24.1 liters. So what happened here? Well, when we added salt into the extracellular fluid, water moved from the intracellular fluid into the extracellular fluid. So the extracellular fluid expanded in volume and the intracellular fluid decreased in volume. And this is what we see right here. So that's it for this video today. I hope this video helped you understand how these different things affect the ECF and ICF, and I hope to see you in the next video. Thanks for watching, and I hope to see you next time.